Okay, today we're going to review how to solve quadratic equations by factoring, also known as using the zero product property. First type of quadratic equation we're going to look at is a difference of squares. A difference of squares is just a special case of quadratics where you have two perfect square quantities separated by a subtraction sign. And it's always factors to the same pattern when this is the case. Okay? Note this does not work when it's a plus sign between the square quantities. Both quantities need to be perfect squares. In other words, if you take the square root of 25, you get 5, a whole number. If you take the square root of 49, you get 7, a whole number. That's a perfect square. So if we were to solve these, get them factored, x squared minus 25 factors to x minus 5 times x plus 5. And if we're solving it, and then it's set equal to 0, then our two answers would be x equals 5 and x equals negative 5. Second one here would factor as x minus 7 times x plus 7. And x would be 7 and negative 7. Next one, the square root of 4x squared is 2x. So the first quantity is going to be 2x. Square root of 25 is 5. And then you just make one of these positive and one negative. So the answer to this one, x would have to be plus or minus 5 halves. So do you remember how to find that if it looks fractiony? Like the first two were easy to figure out just by looking at it. But if it's fractiony, then just take it to the side and solve it. And that's how we get the 5 halves. Okay, and then the last one, 16x squared minus 1. Square root of 16x squared is 4x. Square root of 1 is 1. One's positive and one's a negative. And then we can figure out what x would need to equal. In this case, it would be plus or minus 1/4. Okay, the next type, nicknamed the simple diamond problem. This is when, if you're looking at the standard form of a quadratic, when a is 1. So in other words, when a is 1, we don't even write the a. So, excuse me. Okay, so the simple diamond, there's a shortcut. You don't have to do the X box. If a equals 1 here, then all I have to do is the diamond, and that will tell me how to get it factored. So, for example, this one would be 3 on top, negative 4 on the bottom. Two numbers that multiply to be the top part and add up to be the bottom part. So in this case, it would be negative 1 and negative 3. So this is how this one factors. X minus 1 times x minus 3 equals 0. So x would be 1 and 3. Looking at this next one here, x squared minus 10x plus 16. So we do the box, it's going to be 16 on top, negative 10 on the bottom. So two numbers that multiply to be 16 and add up to negative 10. So it's going to be negative 2 and negative 8. So this one factors x minus 2 times x minus 8. And our answers would be 2 and 8. Looks like I'm running out of room, so I'm going to not do this one. So let's skip down to x squared plus 7x plus 12. Two numbers that multiply to be 12 and add up to 7. Be a nice 3 and a 4. So this would be x plus 3 times x plus 4 equals 0. So our answers would be -3 and -4. So simple diamonds, check for, is the A equal to 1, then try the diamond. And then if the diamond works, then it's a shortcut to getting it factored and finding it. So the one big mistake, though, is when people encounter a quadratic where A is not 1 and they try to factor it like it's a simple diamond problem, and then that's a mistake. So it's when A is not equal to 1, you could call it the extended diamond. This is when you're going to have to use the Xbox method, or let me change colors. This salmon color is just not doing it for me today. Okay, so we're going to do the X first, and remember, let's put the generic form up here too. This is when you do A times C on top, B on the bottom, just so you know what the X box is here, and then AX squared, C goes here. That looks like a 9. So on the top here, we would do a 3 times a -10, so that's -30, and then positive 13 here. So two numbers that multiply to be -30 and add up to 13. So that would be a 15 and a -2. The sign here is really important to make sure you're getting all the numbers right, because you might have different answers. Okay, so we put AX squared in this corner, C in this corner, and then what the X does for us is it tells us how to break up the 13X. This, when I say X, diamond, the diamond, let's call it the diamond. This right here, 15X plus -2X would be 13X. So one's 15X in one corner, doesn't matter which corner, and the other one's -2X. I like to start at this corner when I'm factoring. So 3x squared is 3x times x. But look across the row here. 3x squared and 15x both have a factor of 3x. So I'm going to put the 3x here and the x on top. And 3x times positive 5 is 15x. X times -2 is -2x. So the edges of the box here is how it factors. So to find x, then we just solve each of these separately. You don't have to write this workout if you can do it in your head. But for this one, x would be 2/3. And for this one, x is -5. So our two solutions are 2/3 and -5. Okay, something to watch out for is make sure you're factoring out a common factor first. So looking at this little binomial here, I'm noticing a factor of 3 that I could factor out first. So that'd be 3 times x squared minus 9. Okay, now what I'm seeing is that x squared minus 9 is a difference of squares. So this can be factored out further like this. Now, if I'm solving this, the answers here would be 3 and -3. The factor of 3 out in front, how does that contribute to the solution? Well, it doesn't really, you'll get the same solution as if you we're just solving for x squared minus 9 equals 0, right? But the 3 is a skinnier parabola with the vertex at a different spot. So 3 times the quantity x squared minus 9 is a different parabola than just x squared minus 9, but they have the same solutions, 3 and negative 3. Okay, let's take a look at this next one here. If you look at 5x squared, 25x, 30, I see a factor of 5 that I could factor out. So I'm going to factor out a 5 out of the whole trinomial first. And when I do that, I see that what I could do here is factor. Now what I have in here is a simple diamond problem that I could factor real easily with just a little diamond. So 2 numbers that multiply to be 6 and add up to negative 5 be negative 2 and negative 3. So this thing factors as 5 times x minus 2 times x minus 3. I'm not going to finish solving that. I'm just going to get it factored, okay? So let's just pretend we're factoring this as an expression. Okay. Okay, let's do a different color. What should we pick? Purple. Okay. So this last one here, I do see a factor of 2 that I could factor out. And then I can see if the stuff in the parentheses is factorable by trying this. 2 numbers that multiply to be negative 15 and add up to negative 1. Oops, I made a mistake. Ah! Back up, back up, back up. If I knew how to edit these, I would save you guys this hassle of listening to me scream at myself, but I don't know how, and I don't feel like learning. I like to learn as a person, but sometimes it's not worth the time for this. Okay, so if I factor out a 2, that would be 2x squared. So this isn't a simple diamond inside. This is going to be an extended diamond problem. So this will be a negative 30 on top and a negative 1 on the bottom. So that's going to have to be a negative 6 and a positive 5. I'm going to have to do this thing here. 2x squared. Negative 15 goes there. Negative 6x and 5x go here. And then I get this factored. And so my final factoring here is I've got the 2x plus 5 times the x minus 3. Okay, so watch out for common factors because they can make you think you're done factoring when you've only factored the common factor out, when really you could factor some more. This is going to be important next year when you are dealing with polynomials in Math 3. This particular section, please make sure you know how to do all these things. I feel pretty good about what you guys know on this because I feel like we spent a lot of time on it. Charlie, I am so angry at you for waking me up at 3 a.m. I don't even want to talk to you right now. My cat and I need couples therapy, but I can't afford that right now, so yeah. Anyway, I hope you're having a great day. Bye.